In this video, we're going to launch Module 2, where we talk about the scientific method. Now, before we get into the nitty-gritty details of the steps of the scientific method and kind of what that entails, I just want to talk really big picture about why is this method so important and what are we trying to accomplish with it, aka what is the purpose of doing this? I would say that a very succinct and good definition of the purpose of the scientific method is to objectively and accurately determine how the world works. So if we kind of look at this statement that I've written, I would say that the latter half of this statement, the determine how the world works, I would define this as sort of the goal of science. This is what scientists are trying to do. And, you know, the different disciplines within science are kind of tackling different aspects of the world. But whether you're a physicist or a chemist or a biologist, ultimately that's what you're doing, is you're trying to figure out how the world we live in functions and works. Now, kind of the follow-up question is, why do you need a method to do that? Well, the problem is that the people who are trying to figure out how the world works are human. And humans come with human flaws, right? Sometimes we are biased. Sometimes we zero in on individual flukes or data points. And so we need this method to help keep the process objective and to make sure that we come up with an accurate conclusion. At the end of the day, so if we kind of are now like defending this, we don't want conclusions based off of biases, okay? You know, humans carry lots of biases that can influence the conclusions we make, and sometimes then we don't end up with accurate conclusions. We don't want conclusions that are based off of flukes, right? Flukes are one-off events, but again, don't reflect kind of the average response you're going to get. We don't want that either. Basically, we also don't want conclusions that are based off of, you know, poor design. So the way that you go about answering a question can sometimes lead you to incorrect answers. And we want to make sure that's not the case either. So the whole point of the scientific method is to provide a framework of figuring out how the world works with safeguards in place that are going to prevent us from making conclusions based off of biases, off of flukes, and are essentially going to help ensure that the result that we get is based off of evidence and that it's a reflection of reality. Now, the scientific method is employed within scientific studies. There's a lot of different kinds of scientific studies if you kind of get into the nuances of it, but a lot of those can fall into sort of two very broad study types: observational studies and controlled experiments, which we're going to compare and contrast here. I find that you can actually glean a lot about these studies just by looking at the names and defining what the terms within the names mean. So observational study, observe. What does it mean if you're observing something? Well, if you're observing, then it usually means that you're watching, but theoretically not intervening. And that's a pretty good illustration of an observational study to an extent. Kind of what I would say about an observational study is that the subjects do not get assigned a treatment. Rather, they self-select. The treatment is a term that's used to kind of describe the variable of interest. And essentially within an observational study, we're not going to tell the subjects what treatment they're going to receive. They're sort of choosing that with their natural actions. And I would say another kind of characteristic is that there is overall little intervention behalf of the experimenter. So the experimenter is really not going to manipulate the subjects very much, hence it's observational. We're kind of observing what the subjects are going to naturally do and what treatments they naturally select for themselves with their decisions in life. This is very opposite of a controlled experiment. So control. If you are controlling things, then you are exerting your influence over them. So kind of to provide some contrast here, in a controlled experiment, the subjects are assigned their treatment by the researcher or by the experimenter. So they are told within the confines of this experiment, you're going to be receiving this treatment and we're going to observe something from you as a result. And then there's going to be a lot of other additional intervention besides just which treatment you're assigned. Basically, what's going to happen is that the factors besides the treatment will be held constant. So kind of the idea behind a controlled experiment is we're going to have one treatment that we allow to differ between groups. So this group gets this treatment, this group gets that treatment, and so on and so forth. And then we try to, as much as humanly possible, to keep every other aspect of those subjects as similar as possible. Okay, so there's a lot of intervention on behalf of the experimenter regarding the subjects. Now, what are we trying to accomplish here? So what conclusions are we really looking to make? What's the purpose of each of these studies? Well, I would say that the purpose of the observational study is to see if there is a relationship between two variables. So we're basically looking to see, okay, if people choose to do this, what outcomes do they typically have as a result? Okay, or does partaking in this activity increase the likelihood of this outcome? Ergo, if you increase one of these variables, what happens to the other one? That's kind of what we're looking for here is there a relationship between variables within the study? In a controlled experiment, we're looking for a slightly different type of conclusion. We're mainly looking for a cause and effect conclusion. Cause and effect is basically where I say, okay, if I change this, it's going to cause this other thing to happen. Okay, I'm not just looking to see if they tend to trend in one direction or another. I want to know if this variable is causing the changes in the other variable that I am mentioning. Okay, we're able to do this in a controlled experiment because only one thing is manipulated. So this can only happen when only one variable is changed at a time. And that's what a controlled experiment does. It changes the treatment between groups, but it keeps the other factors constant. And that's going to allow us to say, okay, if we're seeing changes in something that we're measuring, we know that it's because of the treatment and not something else. Observational studies are going to make a cause and effect statement impossible because multiple things could be different between subjects since we're not really intervening to control them. So I would say that's one of the main drawbacks of an observational study is that you cannot make cause and effect claims. Oops, sorry. And again, the reason why is because more than one variable has likely changed between subjects since we didn't intervene to control it. Now, the drawback of a controlled experiment, because at this point people are like, well, shoot, if I want to say this causes that, then I want controlled experiments. Why ever do an observational study if you can't actually make a cause and effect claim? Well, there are drawbacks of controlled experiments. I would say kind of, I guess, twofold. Sometimes these controlled experiments might give you artificial responses from subjects. Sometimes subjects don't respond the same way in a controlled environment like they would in a natural environment. And therefore, the responses you might see might not be a reflection of what they would actually be like in their normal surroundings. I would say another kind of drawback is that sometimes certain treatments might be unethical and cannot be assigned. Anything that's going to cause harm to a human, for instance, is something that you're not going to be able to assign as a treatment. And so there is no way you could do a controlled experiment and say, yeah, I'm going to apply this to you, knowing that it's going to cause you harm just so that I can see what the outcome is. So there might be times where we're limited and a controlled experiment might not be possible for one of these two reasons. All right, so those are the main study types. What we have here is the steps of the scientific method that would be completed within those study types. And I'm not going to go into all of the nuances because basically what the rest of this module is going to be walking through these various aspects of the scientific method. I do want to just spend time right now to kind of explain their sequence and kind of big picture how this plays out in science. So we always start with an observation, which then leads to a hypothesis and a prediction. Once we have that hypothesis in place, which is our proposed explanation, what we do is we design an experiment, and we're designing the experiment to test the hypothesis. Essentially, the scientific method, the study, is sort of quote-unquote putting the hypothesis on trial. You're essentially trying to evaluate if this hypothesis, this possible explanation, is valid or not. So we want to design a robust experiment to try to get valid conclusions. We're then going to run that experiment and analyze the data, which kind of acts like our evidence. And then we're going to make our conclusion about the hypothesis based on that evidence. So what I like to point out here is that the way that I've drawn this, it looks like a very linear process. You get to the end, you make your conclusion, everyone goes home and is happy, and we have answers. This sequence is the sequence that takes place within a specific study, but if we look at trying to answer questions with confidence, big scale, it's not an entirely linear process. We always end up going back and redoing something. So for instance, let's say we get to the end and we find out, hey, you know what? The evidence suggests that the hypothesis is not valid. It does not look like this is the correct explanation. That data would suggest that it's incorrect. What do? Well, you go back to the drawing board. There's always more than one possible explanation for an observation. So if this explanation isn't valid, then what you would do is you would go and you would come up with new hypotheses to test. Okay. If this explanation isn't correct, let's go back and try to find the one that is correct. Now, a lot of people are like, okay, well, that makes sense. Yeah, if you didn't come up with the correct conclusion, you got to go back and find the correct conclusion. But what about if your data suggests that, hey, the hypothesis does appear valid. A lot of people would be under the assumption you're done, right? You're good. You don't need to keep going. But that's also not the case either. I always tell people that scientists are a very skeptical folk. Having one experiment show that a hypothesis is valid is a great starting point, but no one is going to be like handing out Nobel Prizes from one experiment. Basically, if this was the outcome, we would go back to this stage. And what we would do is we would rerun the experiment. And it likely wouldn't be the same people. Okay, so a lot of times we feel more comfortable if when the experiment is rerun, it's done by different groups of scientists. And the whole purpose of doing this is to increase our confidence in the findings. Remember how we're worried about that whole fluke incident? If we can replicate the results by a different set of scientists running the exact same protocol, then we feel more confident in that outcome. So if you think about it kind of in the big scheme, science is not really a linear process. It's very cyclical. And again, the purpose of that is to increase confidence in the outcomes that we come up with.